The next videos are just going to focus on learning how to draw these Feynman diagrams, okay? You might, it could be a 3 to a 4 mark question in total on paper 2, or it can be just 1 or 2 marks on multiple choice that you might be faced with this. So the important thing is to know how to read these diagrams so you can make sense of them, to pick them in multiple choice, or just to make sense on how to draw and label certain components of the diagram, label the exchange particles, and whatnot. Okay, so usually you'll see in any Feynman diagram, you're going to see straight lines and curvy lines. They all meet together at a point, which is called a vertex. And it just depends on what particles are interacting. In this case, I have an electron going in and out of that vertex. All right, and we have a photon in there. So let's try to understand what this diagram is representing. Okay, well, if I look at it, this diagram is telling me with some experience that an electron is emitting a photon. All right, so an electron is moving forward in time, emitting a photon and causing it to change direction or change or repel. Okay, so all of that happens at this vertex. The vertex is telling me what type of interaction is happening and what type of force mediating exchange particle is mediating that interaction. In this case, this is a photon, so it must be an electromagnetic interaction, repulsion, attraction. We'll figure that out a bit later on. Okay, so when we look at these diagrams, let's try to understand a little bit more deeper into the meaning. The arrows don't represent the physical path. It doesn't say an electron is going down at an angle and coming up at an angle. It just represents the progression through time. So in diagrams, time usually goes towards the right. Okay, so this is time. So an electron is moving forward in time. All right, and somewhere along the line, it emitted a photon, causing it to change direction. All right, now the rules for drawing them, if you just stop, press pause, and write these down, the rules for drawing Feynman diagrams is straight lines are particles. So the straight line in the diagram represents the path of particles. Wavy lines are photons or exchange particles. The wavy lines, like I said before, are photons, bosons, or whatnot, exchange particles. Each vertex has 2 straight lines and a wavy line, symbolizing exchange particle mediated interaction. Time progresses left to right, and sometimes you might see a drawing where time is from bottom up. Okay, so time progresses upwards. So it just depends on the nature of the drawing, but most often left to right. Particles point forward in time, so matter points forward, always forward, meaning if time is going to the right, they point towards that direction. Antiparticles and antimatter, on the other hand, point in the opposite direction. So if this was antimatter, the arrows would be going in the opposite direction. And finally, there's always one arrow entering the interaction and one arrow leaving the interaction. Always. Okay? So if we take a look at a few, this is from page 303. I just redrew these diagrams. Here I have an electron particle. Okay, it's matter, so it's going to the right, not antimatter. It has a vertex where an interaction is going to be happening. Arrow in, arrow out, wavy line. And the photon is the exchange particle, so it must be electromagnetic interactions. Because the photon is leaving after the vertex, it means that photon is being emitted, released. Okay? In this case, the photon is before the vertex, which means that this electron is absorbing a photon, causing it to change direction. So it's receiving that particle. That one was emitting it, now it's receiving it. All right? This particle is E positive. It is the antiparticle of an electron, the positron. And the positron always travels in the opposite direction of time. So if this was time, okay, the positron travels in the negative direction. Now time still is going forward, so this positron meeting at that vertex is absorbing a photon, causing it to change direction, despite the fact that the arrows are going in the opposite. So the arrows don't represent the path it takes, just represents the type of matter it is as it progresses through time. Okay, and then here is another antiparticle, a positron, that is emitting. So if time is going towards the right, it's emitting a photon. All right, now this case is, remember again, time is to the right, so two particles, an electron and a positron are moving through time, and they meet at a vertex. Okay, that's what this is saying. So electron is matter, so its arrow is to the right. A positron is antimatter, so its arrow is to the left. Now this doesn't mean that an electron becomes a positron. This means that a positron and electron meet at a point in time. And if they ever meet, when matter and antimatter meet, they annihilate and turn into light energy, into a photon. So that's annihilation. Okay, electron and positron collide, annihilate, resulting in the emission of a photon. And that is all on page 303, just to help you make sense of it. Okay, so at the end of this video, you should be comfortable understanding why arrows are pointing to the left, why arrows are pointing to the right, the meaning of the vertex, the meaning of the wavy lines, and the positioning of the wavy lines to understand if something is being absorbed or emitted. Okay, an important little part, they could ask you to draw that on an exam. So easy marks if you just practice learning how to draw it. In the next few videos, we're going to talk about some important interactions showing the change of nuclear reactions, ones that we studied, like beta decay. What do they look like in a Feynman diagram?